Okay, right, well let's start with the really basic math operations available to us. Add, subtract, multiply, divide, and 1 minus. You might notice these material spheres have a backplate. It's just an option you can turn on and off here. Some things sort of a bit easier to see on a plane rather than on the sphere. And a few other options that we'll cover when they come up. But so add, subtract, multiply, and divide. 4 basic math operators. Hopefully we remember these from school. When we're dealing with colour math, sometimes these can be a little bit more interesting than what we had before. So combining data together, we want to use add, and so in this case I'm adding the pattern here, checkerboard, what's it, these hexes to the checkerboard. Note I'm only using a single channel here, so the full RGB gives us this kind of coloured checkerboard, and I'm just using the single green channel, and by combining them together we get the two added together. We are in base colour, so we are capping out at a value of 1. So I'm adding these two values together. We're not seeing the hexagons here where the value of 1 is already white. If we were to use this in the emissive colour, for example, you can see the values here are now over 1, so we can still make out a little bit of the hexagoning pattern inside the white squares. So adding things together when we're combining two texture masks or combining two things together, that would be the add node. And similarly, when we're removing information, or we're trying to mask out or knock out information, we multiply. So all of the black areas multiplying by 0, and we're still only able to sort of see what's visible where the checkerboard is white, and then we've got that pattern coming through. Subtract and divide obviously work very similar to add and multiply, and they make sense to use occasionally, but they're actually ever so slightly more expensive. So adding things together, it doesn't matter what order you add things together, it's order independent, same with multiplying, but with subtraction and division you have to care about which operator comes first, and so often rather than multiplying by 2, or rather by dividing by 2, you'd multiply by a half, just as a very slight optimization and keeping things slightly quicker. I believe, although I may not be right about this, that Unreal will make those adjustments on compilation anyway, and so if you have used divides, it's just going to work out what it should be multiplying by instead of dividing, so I wouldn't worry about it too much. But these operations are ever so slightly more expensive than these ones. At least that was my understanding. Okay, we'll be using adding and multiplying a lot during kind of building up various materials, just combining different bits of data together. So when we're dealing with our textures, it takes it per pixel, and so if we have a look at our green channel, that's what we're using. Each of these pixels obviously is black. If we're adding, it's going to add the pixel to the corresponding pixel in the other texture, black being 0, white being 1, and it's just going to combine those together either by adding them together or multiplying. Hopefully when we're making materials and actual examples, it should be obvious which one we're using at the time we're using it. There we are. Okay. Just quickly on the next one, we have the 1 minus node. Now the 1 minus node is basically a special case, but all it is a subtract, and so it takes the input value and then it subtracts it away from 1, and what that means is if the input range, the values here, are all between 0 and 1, then effectively it just inverts them and flips them, and so it's kind of inverting around the 0.5. But actually it is just a subtract, and you can see these two outputs here are exactly the same. So the input texture, and I've just kind of done that multiply trick again so I can see what's happening. So the green channel here is a series of black and white squares displayed as black and red because of how Unreal displays things, but we can see by subtracting 1 from that, everything that was black, that was 0, 1 minus 0 is now 1, so that becomes white, and 1 minus 1 becomes black. If I change this to a texture that has some grayscale noise, say tiling noise, that'll do. Turn on live update. You can see it's doing that invert. So here's the black and white noise, and anything that was black becomes white, and anything that was white becomes black. And so we're swapping those around. So yeah, literally no difference between using 1 minus or just a subtract node, but it's such a common sort of thing to do, inverting something, inverting a texture, that it has its own special case node. Okay, right. Okay, I think that's enough for this video. We'll do more in the next.